So let me know when you see my screen.
Yes, we can see your screen.
Perfect. Just a second. Okay. So about myself, I am TVR Prasad. I have experience in infotainment production programs based on Android and Linux. Pretty much into automotive for almost 15 years now. And then I play around with my Odroid C2 and Dragon Board 410C, which unfortunately are slightly on the which don't really support the latest versions of Android. So I'll have to find something better for working on the latest versions of Android. That's about myself. And in terms of the agenda for today, as I mentioned, this is more towards the automotive side of things.
Good.
So I will try to cover, certain parts of bug report that we use in our day-to-day uh, work. So the agenda is more like the power settings, the car power settings, the binder parts of it, the network parts of it, the display, and some miscellaneous parts of it. Okay. Uh, if a lot of things might be familiar to a lot of you, so if it is redundant, please excuse me for that. So, with respect to car power, basically, a lot of issues that we deal daily with customers is that whenever you do ignition off or an ACC off, certain peripherals are supposed to be on and certain peripherals are supposed to be off. The OEMs can actually define the power policy for the vehicle, and a lot of issues that we encounter are like Wi-Fi is not supposed to be on at this point of time, but Wi-Fi is still on at this point of time, or ether Bluetooth was not supposed to be on at this point of time, Bluetooth is still on. So these kind of issues are something that we encounter every day with a lot of our customers. And the first thing that we try to do is, from the bug report, we actually try to uh, look at the car service or the car power service dumps, which actually gives indication of the power policy that is actually active now, and what are the components that are actually enabled in the power policy at that point of time. For example, if you see here, the power policy initial on is a policy that is defined or registered, which has the components audio, display, and CPU are enabled during this stage, and all the other features like media, Bluetooth, and Wi-Fi cellular, all of these are actually not active at this point of time. So this is like very early in the boot stage where this policy gets applied, and majority of the profiles, majority of the peripherals are not active at this point of time. The system power policy all on, this is when we actually receive the AP power state request on from the vehicle processor, and which actually is an indication to turn on all the peripherals. So if you see here, when the power policy all on is actually enabled, we have everything actually enabled, including projection, NFC input, everything, and the components that are disabled are none. Okay, and Android actually allows us to define a lot of various power policies and transitions, and what they call the power policy groups, to identify or to set what is on and what is off, and all this can be actually defined by the OEM in an XML called powerpolicy.xml. Okay, so the first thing when we get an issue with respect to a peripheral not being enabled or being disabled in a particular state is we actually look at the bug report to understand whether the peripheral is actually set as enabled from the bug report, and then that actually allows us to understand if it is the policy that is actually wrongly defined, or if there is something else that needs to be corrected. So this is with respect to the car power policy. Can I go ahead to the next slide, or do we have any questions here?
Nope, it's all good so far, I think.
Okay. The second issue that we majorly run into in our day-to-day life is that uh, whenever the ignition and ACC are turned off, the system actually enters into what's called as a garage mode, where Android defines and the OEM can also define a set of jobs which are run by the job scheduler in what is called as the garage mode, where the display and everything is off, but it just finishes off the jobs in the garage mode and then it actually completely goes down. Typically, Android allows a garage mode time of 900 seconds, which is around 15 minutes. Uh, but typically, the issues that we get are, the system is not going down. There is something that's happening. Please look into what's happening, etc. Why is the system not really going down even after ignition off and ignition on? A lot of OEMs actually run the OTA update or the over the air update jobs in the garage mode. But there are a couple of other Android specific jobs that run in the garage mode. So what we do is we actually take a dump of the job scheduler, and the job scheduler dump actually gives me a list of jobs that actually are scheduled for the garage mode, and that also tells me, okay, that these jobs are still running, uh, and they are actually keeping the system alive. One thing that we need to be aware of is that in the garage mode, USB might not work. So typically what we do is we actually use ADP or Wi-Fi for the garage mode, to take a dump of the jobs that are actually running in the garage mode. So as you see here, the some of the jobs that we actually captured here, these are all jobs that typically run in garage mode. For example, this actually needs, the required constraint is that device idle is equal to true, which means that this is a job that needs garage mode to be active for it to be run. Whereas the one on the left side does not really have to be a garage mode. The device idle is false, which means it is a job that can run even normally and not specifically something that's marked for garage mode. Okay.
Cool. Can I just ask you a couple of things? You refer to ACC. Can you just elaborate what ACC stands for?
Okay. To be honest, I don't really know what ACC stands for, but it's like this. Uh, when you actually get into a car, which typically has a key, okay.
Mhm.
So the first thing that you do when you power on, when you put in the key and then you turn it on, is actually ACC, where it gets the first power on, but it's like the ignition is not yet done. You are still draining the battery. You are getting the power from the battery, and when you do the ignition, that's when it actually switches from ACC. Actually, ACC is accessory. Sorry for that. Accessory. Okay, they call it
Mhm.
accessory on. So when you do an accessory on, you still have the infotainment up and running, but it's getting the power from the battery. And when you do an ignition, and when the vehicle is actually in moving condition, the it actually gets the power from an alternator.
Okay, cool. The other thing I'd like to ask is, can you explain a little bit more about garage mode? What does garage mode do for you?
Okay. So, good. Basically, it's like this. Now, let's take a case where I have a pull-based OTA update. So when I say a pull-based OTA update, it's like this, where the car, when you actually turn off the car, okay, there needs to be a mode where it can go and check if there is a OTA update that is available for the car, for this version of the car. Okay. Now, and then when the OTA version of, when the new version of software is available for the car, you actually go and hit the server and get the package and update the, do the update. Now, typically what happens is a lot of such tasks which can be done in the background without really hampering the user experience or without really needing the user to get involved. All of these tasks, or for example, I want to do a file system check on a read write disk that is there. Okay. So
Okay,
all
cool.
of these tasks actually are done in a mode called as garage mode, where when you actually turn the ignition off and the ACC off, and just before when it completely does a shutdown, there is this mode called as garage mode, where what happens is the jobs that are registered with the job scheduler service are run in the garage mode, just like the services that I just told you, right? The OTA service where it tries to connect to the OEM server, the campaign server, and then try to see if there is an OTA update, and the file system check, because now I'm just going down. I can actually unmount the read write partition and run an FSCK on it and make sure that the file system is actually in a good condition. So these kind of jobs. Apart from this, there are a couple of other things where Android does, like if there are any new packages that are installed, they check, or they also check if there are any dex, if there is any dex optimization that needs to be done for any package that got installed recently, etc.
Okay, cool. Thanks. Okay,
Okay.
that all makes sense.
Sure. Thanks. This is more about car power. Now I will try to spend some time on binder. So a lot of issues that we encounter, especially with the newer versions of automotive software, is that, for example, one of the issues that we have run into recently is when there is a user switch. Okay, there's a driver and the passenger, and then, or there is a new user who's actually taking over the car. Now, when the user switch happens, there are some situations where things are not working as expected. Okay. And when we actually look at the bug report, we find that there are a lot of binder transactions which failed, and these binder transactions are actually the reason why the behavior is not expected. Okay. So a bug report typically has what's called as a binder failed transaction log, similar to what you see here. Okay. And so here 1559 refers to the PID from where the transaction originated, and 1572 refers to the thread ID in which from which the transaction originated. The 00 that you see here are actually supposed to be the destination PID and TID, destination process ID and thread ID. So the thread ID 0 indicates that there is, as of now, there is no thread that is dedicated for handling this request, and the kernel or the binder driver needs to actually create a new thread to handle this request. And in some cases, basically, the 0 in the destination PID indicates system server. Okay. So from this we try to understand, okay, that 1559 tried to do a request to the system server which did not go through. So we try to understand what is 1559 and what is the binder transaction, and then the number 29189, it is actually an error code that is written by the driver. Okay. So based on all of this, we try to understand what is the transaction, why is it actually failing, uh, and what is the transaction, who is actually initiating the transaction, and from where is it ending up. And the length of the binder work queue at the time of the transaction uh, indicates basically how many more binder transactions can this work queue handle. Does it have enough space for binder transactions to be processed. And at this point of time, it says that the binder that it can still handle decent amount of binder transactions and it is in good health. Okay. Apart from this, there are cases where the binder transactions are failing because the the number of threads which are supposed to handle uh, the binder request, they have already overshot the max number. Okay. So what we do is we actually look at the binder stats, and the binder stats for a process, for all the process get dumped actually. And for from the previous slide, when we identify, let's say, the PID, the transact from the transaction, we try to look at whether the threads for that, whether the requested threads for that basically, and the ready threads for that are in good shape or not. So the requested threads, as you see here, 0 plus 4 by 15. So the first number 0, it indicates that it's an implicit request from the process to actually uh, start a binder thread to handle the binder request. The plus 4 is actually the number of threads that the binder driver creates to handle the incoming request. The number 15 actually represents the max number of threads that can be created. Okay. And the ready threads actually indicates the number of threads which are ready in a ready state. So it means that the process has 5 threads which are in ready state, so they can handle incoming requests at any point of time. Okay. So from all of these we can actually identify if the binder threads are actually starving, or if the process is starving to handle incoming binder requests. Okay. So if this number 4, if this is around 15 or 14 or 12, this means that the incoming inflow is actually on a higher side. So it's always an indication that it's better to actually increase the binder thread pool max size. Okay.
Okay.
uh, this is with respect to binder. With respect to network, I have not really shown the content of all of this, but uh, typically what happens in a cockpit. So in a cockpit, when I say an automotive cockpit, we have we have the cluster and the infotainment and the passenger screen and the heads up display, etc., all of them running from a single SoC. Okay. So, or with the new HPC kind of architectures that are coming into automotive, uh, where things are completely networked. I have a QNX based hypervisor on which we have multiple VMs running, and then they are all connected over network. So it's important that we understand the network architecture and we get a feel of how the network is actually done and all of that stuff to understand if a particular request is routed to the correct ECU or not, if a particular request and if the routing tables are correct, etc., all of that stuff. So bug report dumps a lot of network information. uh, for example, as you see here, a detailed socket state, SS stands for sockstat, is actually dumped. The IP link, which actually gives you the link status of all the network interfaces available. IP address show, it shows the IPv4 addresses of all the network interfaces. Same thing. This is important. The IP rules and the IPv4 rules and the IPv6 rules. Basically, it's like if you have set up some firewall rules, basically, we can actually see if they are properly set up, if the necessary ports are only enabled and all the other ports are not enabled, etc. All of that stuff can actually be looked into uh, by all of this. Then it actually dumps a list of routing tables that the system sees, uh, and and it also dumps the multicast addresses and the ARP cache for IPv4 and IPv6. So all of this basically helps us understand the networking architecture and the networking parts of it. In fact, apart from a cockpit, one of the other issues that we have ran into recently is we were trying to bring in Wi-Fi direct support uh, to enable a game controller uh, to actually allow playing games on the infotainment system. Okay, and at the same time, there is this wireless Android Auto that is running. So the Wi-Fi Direct actually uses what's called as uh, the autonomous, yeah, the group owner kind of concept, and the projection wireless projection actually uses a access point for its wireless projection. Now you have two different things. One which is actually communication between the controller, game controller, and the game that is running on the infotainment, and the same Wi-Fi, the different Wi-Fi for the projection. So how are the routing tables set up? Is it actually working properly or not? And am I actually leaving any hole for a from the Wi-Fi direct channel to be exploited? So all of this is something that you can actually extract uh, from the bug report with all of these markers that are there in the bug report.
Okay.
Uh, the other parts of the other issues that we typically use bug report for is with respect to display. Now, as I mentioned earlier, where we have more than one display that's running, so there are issues that are mentioned, like there is a screen flicker, there is a I was expecting the projection to come up, but I see a black screen, or the user was supposed to have something like uh, something like an animation, but there's a black screen that came up, etc., all of that stuff. Okay, so basically we look at the dump for the surface flinger, the hardware composer, etc., to understand what is actually being showed on the display, as you see here. And we then realize, okay, it's now settings, and then you also have the Z order, the window type, and the transformation that needs to be applied, etc. All of this stuff is actually captured here. From all of this, we understand, okay, the Z order seems to be fine, but why did the new layer come up? So we try to understand in those lines. Typically, you realize that the Z order, majority of the time, it's going to be the Z order, which is actually not the expected type, which is giving the issues like that I mentioned. Okay, so the bug report typically tells us if the Z order is fine and it is actually showing what it is supposed to show. Okay, continuing on the same, we also look at the window manager's dump, and we look at, okay, if what are the windows that are there on the screen that are coming up. Then we look at the type of them to understand basically how is the final surface going to be composed. Like, let's say if it's a display overlay, or is it like a translucent thing, or it's a navigation bar panel, or is it an application overlay dialog that is supposed to come, which is actually showing up as a black screen. All of these things we look into to understand uh, what is that is actually getting shown on the screen. Okay, by the way, these are all constants: the base application, the types that you see here, right? The base application, the type overlay, the navigation bar panel, these are all, or the display overlay, these are all constants that are defined by layout params of window manager, which actually give information about the window type that is being shown. Okay, so all of these information we actually try to digest, and then come to a conclusion that the black screen or whatever is suppose that's coming up is actually an overlay or a projection screen that's getting projected, which is a different panel, etc. All of that stuff. Okay. So unfortunately, I don't have any audio use cases that I have captured because of confidential reasons. I don't have a bug report with which has audio, and the bug reports that you have seen here, they're all from a cuttlefish instance. Okay, so typically we can also extract a lot of information on audio, like the players, the audio track, who's using the audio track, who's using the audio record, sorry, the process is using audio record, the process is using audio track, the process is having the focus, etc. All of that stuff is actually dumped in a bug report, but due to confidentiality reasons, I don't have them captured in the slide deck. Okay. Apart from this, there are a couple of other important miscellaneous things that are captured in a bug report and help us debug issues. Uh, the native services backtrace. This is a very very important tool for uh, debugging some issues. So to give an example, one of the issues that we have recently resolved or worked upon is uh, when the infotainment is actually going into the suspend state. It's basically they were trying to do suspend to RAM to make sure that it comes up quickly in the next ignition cycle. So when it was going into suspend and the user did an ignition immediately, what happened is the audio server crashed. Okay, the audio flinger crashed, and looking at the backtrace basically of the audio flinger, it was saying that it actually ran into a binder timeout. Okay, it actually ran into a audio server binder timeout. So the audio flinger was supposed to be analyzed on why it actually ran into a binder timeout. So what happened is when we saw the backtrace of the audio server, we realized that the audio server was invoking set parameters on the audio HAL, and the audio HAL team was actually mentioning that the set parameters never reached the audio HAL. But thanks to the native services backtrace, we could actually identify a binder thread where we could show them that the set parameters reached the audio HAL, and in fact, it was actually timing out in the audio HAL. And the reason was the audio HAL was taking a bit more time to suspend or come back from the suspend state to the resume state. Uh, and that is the reason why the audio flinger was actually crashing. So the native services backtrace really helps to understand the thread state. When some of these issues happen, like, the native services crashes or something like that. This really helps, and uh, and then the part that you see here, the binder 465.2, the binder VND binder 465.1, these tell that this thread is actually handling a binder transaction or a binder request that has come from a different process. And uh, when we combine this with the binder transaction log or a systrace, it becomes easier to understand how or which process is actually invoking this transaction. Okay. Similarly,
Can I just interrupt you for a moment? You're kind of come to the end of your slot. I wonder if you could just quickly summarize and then take any questions that there may be.
Sure. There is just one more slide. I'll just finish that
Okay,
off and then I'm
brilliant.
done. Okay. So this is with respect to the native services backtrace. Uh, and then there are a couple of other simple things that we look into: the CPU consumption, the IO, the IO weight. Basically, it's like if there are processes waiting too much for IO weight, it means that there is some other issue that needs to be looked into. The other important thing that we typically look at is the number of kills that the low memory killer has done. This is important. For example, one of the issues that we run into, especially with Chromium or the WebView, is WebView just kills or when you load a page which actually consumes more than 200 MB of JavaScript, it just kills uh, Chromium WebView, the process basically. So we try to look into the low memory killer, but it doesn't get killed through the low memory killer. It's the Chromium engine inside that actually tries to kill things. Uh, so basically, it's like the low memory killer information that you see here. This is also important to understand if a process got killed because of the low memory killer. That's it from my side. Thank you once again for hosting me.
Okay, thank you. Does anybody have any questions? Oh, can you stop sharing your screen in a moment, please?
Sure.
Cool. Yeah, any questions? All fans of Bugreport?
Sounds cool. No? Maybe, Prasad, could you please click on that red button on the top, which says stop share? Perfect. Thank you very much.
Hi guys, can you hear me?
Yes, we can hear you.
So I have one question, which might be stupid because I missed first few minutes. How do you get all those information that you showed? I mean, what kind of automation collects all that?
Okay.
Is this some generic bug report functionality from Android or something extra that does all this job?
It's generic bug report from Android.
Okay, thanks.
I think there is as Prasad says, the bug report, and you can also always do ADB shell, and then inside the ADB shell you can do dumpsys. I think in the slides of Prasad you can actually see the commands he was executing, like dumpsys, surface flinger, or dumpsys something else. Dumpsys on itself will dump all the information about all services, and then you can provide a specific service at the end, and it will dump a specific part of the system.
Okay, thanks. So I was aware of this dumpsys tool, but I was not aware about this bug report functionality, surprisingly. So this will help in the future. Thanks.
I am not 100% sure. I would guess, maybe somebody knows better. I would guess that a bug report is basically a dumpsys collected in a log file and zipped for sending it to some kind of a server. So if you are using like a device remotely and you want to send a dumpsys, like a dump or a report, bug report to your, I don't know, OEM or to the company who built that, it's Android in the background will actually call dumpsys, collect all the data, put all of that and some more inside the zip package, and then offer it for you to either send it via email or maybe upload it somewhere. So this is basically the same tool, but dedicated for using by a different way, I would say. So this is what my experience is. I'm not sure if it's correct.
Yeah. So apart from dumpsys, it dumps a lot of other information like the native thread state that I just mentioned, right? And then a lot of other information about visible windows. In fact, the Bluetooth lower level HCI logs, what we call as the host controller interface logs, all of that is also embedded into it. And then it's a dump of the system state at that instance that actually is. And then ADB bug report is a command that you can actually use to generate it. And then, yeah.
But I guess it's quite neat that with a single command, you can capture all this information in one go in a standard format. And then you can download it and analyze it offline as and when. So yeah, all operating systems should have one of these. Okay, anyone else?
Yeah, so I would like to add, I think it's also available in the UI in settings. Also the functionality to report a bug, not only from ADB, if I'm not wrong.
It
So
could depend.
Yeah,
could depend
it
on the
depends
OEM.
also. Yeah, that's right. Yeah, I mean the original vanilla settings. Yeah, I think they have it, and yeah, this also allows to collect. Yeah, as you said, dumps of services, logcat. Yeah, and some tombstones. So some native services that died in the meantime. Yeah.
Okay. Super. So I'd just like to say thank you very much to Prasad.